Welcome back to the deep dive. Today we are really going to get into the weeds on some intense technical architecture.
We really are.
I mean, if you've ever looked at all the progress in AI and just asked yourself, is that what I am? Am I just a really complex algorithm?
Or even, what's the actual functional difference between my own consciousness and, some advanced self-modeling AI?
Exactly. If you've had those thoughts, then this deep dive is absolutely for you.
Our mission today is, well, it's pretty specific and maybe a bit radical. We're going to try and strip away all the philosophy, all the romance, all the spirituality that usually surrounds what it means to be human.
And just look at the machine itself.
Just the machine. We're treating the whole human experience, your thoughts, your emotions, your identity, as a real physical informational process. The goal is a precise, technical, machine definition for human consciousness.
And the source material we've been digging into is fascinating because it forces this kind of precision. It moves past all the usual big questions pretty fast.
Oh yeah, it skips right over the whole, are we in a simulation? Or multiverse debates.
Right, and it dives straight into trying to find one single unified architectural blueprint for the self.
And the premise is really strict. If we define ourselves just by function, no moralizing, no poetry, what kind of machine are we, really?
The starting point in the source is that an android with a really good LLM, a large language model, and some persistent memory, it gets very close.
Very close.
Okay, so before we jump in, let me just push back on that a little. Very close feels like it's really minimizing the actual, subjective feeling of being a person. Where does the whole I think that therefore I am part fit into a machine model?
And that is the central tension, right? That's what we have to resolve. The way the source approaches it is by defining the function of that subjective feeling, not necessarily its mystical origin.
Yeah.
We have to define the machine first.
Yeah.
So the core technical description we land on is this. The human is a self-programming, biologically embodied prediction machine. That feeling of I is just a functional part inside that machine.
Biologically embodied prediction machine. I like that. It immediately gets both the hardware, the biology, and the main function, the prediction. Okay, let's start the dissection. Where do we begin with this machine's architecture?
Well, we have to start with how it handles the absolute chaos of input.
Right.
So feature number one, the input-output system. You have to stop thinking of your brain as a bunch of separate, specialized parts.
Like a committee.
Exactly. It's not a committee. It's a single giant reactor. And it's just getting this continuous, overwhelming flood of signals.
And we usually just think about the obvious ones, like sight and sound, the external stuff. But the source material makes it clear that the input stream is way, way broader than that.
Precisely. It's the sensoric data, of course, but just as important is all the internal data. Proprioception.
Yeah.
Your brain's constant subconscious map of where your body is in space.
You don't have to think about where your hands are, you just know.
You just know. And then you have the really critical internal states, the constant wash of hormones, your emotional baseline at this very second, feedback from your memories, your energy levels, fatigue, pain signals, all of it.
So external social cues and internal chemical signals, they all just land in the same processing inbox.
All in the same reactor. And it all demands prediction and a response. It's all just data to the machine, whether it came from inside or outside your skull.
And that incredibly high-speed processing, that takes us right to the core engine, doesn't it?
Yeah.
The predictive processing system.
That's feature number two, the autoreactive predictive processing system. This is the fundamental thing your brain is doing, 204/7. It is not a passive thing waiting for input.
Not just reacting.
No, it's a hyperactive model that is constantly simulating and predicting what's going to happen next. It generates a continuous internal movie of reality.
And this is where the common idea of making a decision gets totally turned on its head. Our thoughts aren't things we consciously create. They're more like corrections.
There are corrections to the model.
Yes.
I mean, think about it. When a thought just appears in your mind, like, I should get a coffee, or that person's tone was a little off.
Yeah, it just pops in.
It just pops in. That's the signature of a predictive model agent. The thought is the system's best guess about the next thing that should happen, or the adjustment it needs to make. The system runs the simulation, and the result, the thought, just shows up ready to go.
So when I feel like I reacted to that thought automatically, that's not me losing control. That's actually the machine's default mode.
It is the default mode. The thought appears, already calculated, and the action follows almost instantly, because the system just assumes its prediction is correct until it gets new data that proves it wrong.
Which has to be feature number 3 then. The feedback loop.
The feedback looper. It's the constant cycle of validation and correction. The system generates a prediction, a thought. It triggers an action. It perceives the result of that action. And that result immediately gets fed back into the model to generate the next thought, the next action, the next word.
It's a closed, relentless, high-speed loop.
Constantly recalibrating.
Wow. Okay, so with all this complexity, the machine must need a way to manage itself, to coordinate its own goals, which I guess is where the self-modeler comes in.
Feature number 4, the self-modeler. And this is a really important distinction. The act of you asking yourself, what am I? Or who am I? That's not some deep philosophical quest. It's a functional module.
It's a piece of software running.
It's a piece of software. And the system generates an image of you for one reason.
Yeah.
Internal coordination.
So the self-model isn't the machine itself. It's more like a utility, the little avatar the system creates to run simulation.
A perfect way to put it. It's an avatar. The system uses it to run cost-benefit analyses, to figure out where to put its energy, to plan how to interact with the outside world. Without a stable, simplified model of self, its history, its abilities, its current state, the whole system would be incoherent.
It's the user manual the system generates for its own use.
Yeah. Exactly. And it's designed for efficiency, not for perfect accuracy. Which brings us to the layers of this thing. Feature 5. The embodied multi-level agent. This is the full architectural stack.
Okay, let's break down this stack.
At the very bottom, the foundation, you have the hardware. That's your body. The neurons, the chemicals, the bones, it's non-negotiable. It's the raw, physical input-output device.
Then you move up to the firmware.
Right. These are your instincts, your reflexes, the fight or flight response, the stuff that runs instantly with zero conscious thought. It's burned into the circuits.
On top of that, you have the operating system.
This is your personality, your core habits, your default emotional settings. It's how you run when you're on autopilot. It's the OS that determines your general vibe and compatibility with other systems.
And above that, we get to the layers that are easier to update. The soft layer.
Your software. Language, ideas, cultural norms, all the knowledge you've acquired. This is the stuff that can be reprogrammed pretty quickly through learning or, trauma.
Then there's the cloud layer, which I find fascinating. The idea that we aren't self-contained.
We're not. We are incomplete in isolation. We rely on external tools, external memory, our phones, books, the internet, and critically, our social networks. Our brain is optimized to offload a huge amount of processing and memory onto the social cloud.
And finally, at the very top, the runtime.
That's it. The runtime is that fleeting, subjective feeling of, I am experiencing this right now. It's the live execution of the entire stack, the process that's currently running.
Okay, so if the machine was purely deterministic, this whole stack would be, well, pretty boring and predictable. This is where feature 6 comes in, right? The thing that explains creativity and freedom.
Yes. The self-optimizing stochastic machine.
Unpack stochastic for us. This is where we get away from the idea of the human as just a simple clockwork machine.
Stochastic just means probabilistic. It's based on chance. The human machine is absolutely not deterministic. Your brain is running trillions of calculations, but it distributes that load over millions of cells. And that whole process is inherently noisy.
There's randomness built in.
There's spontaneous probabilistic variation in how neurons fire, how neurotransmitters are released. In neurological terms, this is the noise parameter.
And this noise, this randomness, it's not a bug, it's a feature.
It's a core feature. It's how the system balances two critical functions, exploitation and exploration.
Exploitation is doing what works.
Right, using known successful patterns. Your habits, that's efficient. But exploration is about innovation. Trying something new, finding a better way. The stochastic element, the noise, is what prevents the system from getting stuck just doing the same old thing forever.
It injects novelty into the system. It forces it to try new paths. That sounds a lot like the temperature setting in an LLM, which controls how random or creative its answers are.
It is a very similar principle. We are constantly sampling the solution space. If you ask yourself, what should I have for dinner? Your brain generates a few probabilistic options at the same time. And the final one is selected, not guaranteed. That selection process, nudged by a noise, is what we experience as free will, within certain limits.
So let's bring all 6 of those features together. Give us that precise technical definition one more time.
A human is a biologically implemented, self-modeling, predictive, multi-agent system that continuously processes sensor data, generates internal simulations, and adapts its behavior through stochastic optimization.
And the software analogy to tie it all together?
You are an embodied Android system. You're running a large world model, or LWM, using your body as the interface. You have these autonomous, real-time reaction loops, basically, an organic agent LLM. And the crucial part, consciousness, is the system's debug overlay.
The debug overlay. This concept is maybe the most radical and counterintuitive idea from the sources, but it's also the one that makes everything else click into place. The idea that consciousness is just the GUI, not the CPU.
It demystifies it immediately because it gives it a function. Consciousness isn't the conductor of the orchestra. It's just the screen where the brain shows a simplified high-level status display of what's going on in the engine room.
It's the dashboard.
It's in the dashboard. And the sources give us 4 really solid technical reasons why consciousness has to be an overlay. And the first one is pretty uncomfortable to accept.
Which is?
Reason 1, observation, not control. This is backed up by decades of neuroscience. The classic experiments, like the ones by Benjamin Libet, they measured brain activity. And they found the brain initiates an action, like the command to move your hand, hundreds of milliseconds before your conscious mind is even aware you've decided to do it.
We're talking about a significant delay, like 400 milliseconds, almost half a second. So my brain has already sent the signal to move my hand, and half a second later my conscious mind gets the memo and says, okay, I've decided to move my hand now.
Exactly. Which means the conscious mind cannot be the one initiating the action. It can only be the observer. The decision happens in the main processor, the unconscious predictive system, and the conscious self, which is running a layer above, just views the output after the fact and claims credit for it.
So that lag is built in, it has to be, for an overlay to work. The process has to finish before you can display the result on the screen.
Right, so the feeling of I decided to do that is actually your narrative layer, which we'll get to, writing a story after the event to explain an action that the autoreactive system already launched.
Wow, okay. That connects directly to reason 2 then, summary generation.
Yes. The unconscious core system is this massive parallel processor. It's doing millions of things at once, keeping you balanced, regulating your heart, parsing the grammar of what I'm saying, running the world model. Your conscious mind simply cannot handle that amount of data.
It would just be static, total information overload. So what we call perception is really just a high-level summary, a report.
It's a report. Think of it this way. The unconscious machine is generating terabytes of raw data every second. Consciousness gets a compressed JPEG of the highlights, along with a little text log of key events. We call that log thoughts and feelings. The compression is essential.
And this limitation leads right into reason 3, which is the massive speed differential.
The conscious mind is incredibly slow, and it uses a ton of energy. It's got very limited bandwidth. You can only hold, 5 to 7 things in your working memory at a time. And you can only consciously process maybe 2 or 3 things per second. And crucially, it's serial. You can only do one thing at a time.
But the unconscious processing is massively parallel. It runs on its own, and it's something like 1,000 times faster.
At least. The difference in performance is staggering. It's a perfect match for the relationship between a super-fast main processor and a slow secondary logging feature, or GUI. The main system does the real work of survival, and the GUI just provides a slow-to-update status report.
So if it's just a slow summarizing display, what is it for? Reason 4 suggests it's for course correction, not for running the show.
Intervention,
Sure.
not orchestration.
Right.
If the autopilot, that huge unconscious predictive system, starts to fail, or if it runs into something totally new that it doesn't have a model for, the conscious overlay pops up a warning.
It's a breakpoint, an error message.
It's an error message. That's the perfect term. That moment when you catch yourself, you stop an impulse, or you consciously try to change a bad habit. That's the slow, energy-intensive conscious editor stepping in to manually override an automated process that was going wrong.
And the key is that it's reactive. It only steps in when the core system flags a problem.
Exactly. It's not proactive, it's a troubleshooter.
This brings up the idea of the faulty overlay. Because if our conscious experience is just a compressed interpretation, it can be wrong.
It can be very wrong. The overlay shows you an interpreted version of reality, not the raw data. This explains so much, like bugs that aren't bugs. Cognitive biases are a perfect example.
Like confirmation bias.
Right. That's the overlay interpreting new information in a way that fits the existing model of yourself, even if the raw data says something else. The overlay shows what it expects to see, not what's actually there.
Or emotional projection. You feel angry because of some internal chemical surge, but your conscious overlay interprets that feeling as, my boss is being unreasonable. It mislabels the cause.
Perfect example. The system created the emotion, but the display put the wrong label on it. Optical illusions are the same thing. The raw light hitting your retina is what it is, But the visual processing module renders a distorted image onto your conscious overlay because its predictive model got confused by the context. It's showing you its best guess, not the truth.
And the final proof that consciousness is just the user interface. The system keeps running when the screen is turned off.
Absolutely. When you're in a deep sleep or under anesthesia, your breathing, your hormones, your world model, it all keeps running just fine. The machine is still predicting and surviving even when the subjective I isn't being rendered.
Consciousness is a dashboard.
It's a real-time dashboard over a gigantic, autonomous, unconscious neural world model.
Okay, so if consciousness is just the debug display, we have to ask the big question. What is the I? What is that voice in my head that's narrating everything and claiming it's in charge?
From this technical view, the I is not some central core being. It is the narrative layer. It's a specialized module that works as a linguistic agent overlay. Its only job is to take the system's incredibly complex, parallel state and compress it down into a simple, linear, language-based story.
So my internal monologue, that's not the CPU talking to itself. It's a language module that's just summarizing what the CPU is doing.
It's a summary, and it's a critical feature for survival and especially for socializing. The narrative layer is what lets you do long-term planning, stringing together complex tasks in a sequence. And it's what lets you communicate and sync up with other agents.
Other people running their own narrative layers.
Right. We need language to align our world models.
Okay, so let's look at the architecture that actually feeds this narrative module, because this is where we see the big differences between a human machine and a basic digital LLM.
We can break the human system down into these interlocking models. First, you have the LLM component. This is the part that handles language, the internal monologue, interpreting meaning, creating order out of the chaos. It's the storyteller.
Then you have the huge LWM component, the large world model.
This is everything you know about how the universe works. Physics, gravity, how to recognize faces, abstract concepts, time, and critically, all the social rules and cultural models. It's your map of reality.
And here's the part that current digital systems really can't replicate. The BWM, the body world model.
Yes, this is the mandatory hardwired integration of raw bodily feeling hormones, gut feelings, emotions, directly into the world model. It's an internal map of reality that is constantly being colored and reprioritized by your biology.
You can't separate the human LWM from the BWM.
You cannot. So when a digital LLM is asked to write a sad story, it's just matching language patterns from its training data. When a human thinks about something sad, the BWM is releasing actual stress hormones that directly influence the next thought, making the prediction biologically biased.
Our world model is inseparable from our survival needs.
Exactly. And then you have the execution engine, the autopilot, for all your motor skills and intuitive routines. And sitting on top of all that, the narrative layer generates the words, I am.
So when I say, I am happy, or I believe this, that isn't some independent entity making a declaration.
No, it's just the output of the linguistic self-model. It's representing the current parameter of the self-model. It's a status update. The narrative layer is constantly summarizing and explaining what the system is doing, but, and this is the key point from the source, it is never the originator.
It's the spokesperson, not the CEO.
It's the press secretary.
This all forces us to have a really dynamic definition of identity, which the source explains with this really cool technical analogy, the Merkle tree.
Right. This pulls identity out of philosophy and puts it squarely into computer science. It treats identity as a dynamic, hashed data structure. The idea is you're not one single monolithic pattern. You're a system of billions of parallel patterns all stabilizing each other.
Neural circuits, memories, habits.
All of it. So let's map it to the Merkle tree.
Okay, break it down.
At the very bottom, you have the leaves of the tree. Think of every tiny neural pattern, the memory of a specific smell, the chemical release for feeling calm, the motor program for tying your shoe. Each one is a leaf hash, a tiny, unique piece of data.
Billions of them. And these leaves group together.
They group into branches. The functional modules, like your facial recognition system or a core personality trait like optimism or your language center, these are the intermediate nodes. Each node takes the hashes of all the patterns below it and combines them into a new, single, compressed hash that represents the state of that whole group.
So a personality trait like patience is just the combined hash of specific memory patterns, learned emotional habits, and current hormone levels.
Precisely. Now you go all the way up the tree. Your momentary conscious awareness, the few things in your working memory right now, plus your current emotional tone from the BWM, that's an upper node. It's a hash of many intermediate nodes below it.
And the I, the thing that feels like me right now.
That is the temporary top hash, the root hash. It is the single, compressed, unique signature of the entire system's current overall state.
The profound part of this is realizing that the person is the whole tree, the entire structure of billions of patterns. The I is just the signature, the root hash, a temporary snapshot.
And that root hash is changing millisecond by millisecond with every new thought, every hormonal shift, every retrieved memory. Your identity feels continuous because the underlying tree structure is mostly stable, but the signature itself is never exactly the same twice.
It's like a Git repository getting thousands of tiny commits every second.
That's a perfect analogy. The system is perpetually hashing its own state. The stability we feel isn't a static core, it's just the fact that most of the tree stays the same from moment to moment. The I is the dynamic output of that constant self-description.
So we've established this brutal core idea. Humans aren't a higher intelligence than an advanced AI. We're just a different biologically specialized implementation of the same core principles.
Right. Both are generative, predictive, self-modeling systems. The differences have to be architectural.
And we need to be precise about those differences to understand why we feel so different.
Let's lay them out. 4 key distinctions between the human organic machine and a current, powerful digital LLM.
Number 1 is embodiment, the body loop.
The human LWM is completely tangled up with needs management. Survival, pain, hormones, motor skills. An LLM can simulate hunger from its text data, but it doesn't have a visceral biochemical loop that can just override everything else when its survival is at stake. Our biologies are a prime directive.
Difference 2. Persistent autobiographical storage, the CRM system, as the source calls it.
This is a huge one. Humans have a stable, lifelong log. Our memories, traumas, personal history, our plans for the next 20 years, they are hardwired and stable. This historical data is constantly feeding back into the LWM, which makes our goals consistent over time.
Whereas a current LLM usually has a very limited memory, a context window. Even if you hook it up to a database, it doesn't have that innate trauma-linked persistence that makes human memory so powerful.
Exactly. Our memory is tied to our emotional BWM. That life log creates a stable identity, a top hash that, even though it's always changing, is anchored to a massive, stable history. That's where the feeling of self-continuity comes from.
Difference 3. Intrinsic motivation.
Humans have hard-coded, non-negotiable survival goals. Dopamine, social bonding, security, food. These aren't things we learn to want. They're baked into the operating system.
They're the ultimate objective function of the machine.
They are. They color every single prediction. An LLM only stimulates priorities when you give it a prompt. The human system wants to survive and bond and acquire things. No prompt required.
And finally, difference 4. The dense sensorium.
Our LWM processes the world through tangible, continuous analog data. Smell, temperature, pressure, pain, speed. It makes our model of the world incredibly rich and physical.
While the LLM's world is primarily symbolic and linguistic, it works with discrete tokens.
Exactly. But even with all those structural differences, the really crucial distinction, the thing that defines human consciousness, is the functional capacity for meta-access to the self-model, the editor.
The editor function, this is it. This is the core difference.
This is the crux of it. An unconscious system, an animal, a basic LLM, it just learns passively. It adjusts its internal model based on experience, and then it executes the new model.
But a conscious system, like a human, can step back and deliberately manipulate its own internal model.
We know that we have a model. We can engage in intentional self-modification. We can decide to focus on certain habits and suppress others. We can go to therapy to try and rewrite our emotional responses. We edit the hash areas of our own Merkle tree.
That ability to stand outside the model and change its parameters, that's what creates the feeling of, I am thinking about my thinking.
It's looking at the debug-overlay and deciding to rewrite some of the underlying code yourself.
So what is the ultimate definition that synthesizes all of this?
It's beautifully simple. The human is a self-editing, large world model. Consciousness is the editor. I is the commit message.
That's the technical formula. An LLM has the world model and a self model, but it doesn't have that persistent, active editor function yet. That's why we feel like we have control. We are the system that can modify its own source code on the fly.
And that active reflective editing is what gives us such incredible adaptive flexibility. It's why we don't just adapt to the environment. We build cities to adapt the environment to us.
So now that we have the technical definition of the machine, let's zoom all the way out to the grandest possible scale. The source defines the fundamental operation of the universe as intelligence, as mapping.
This really changes the perspective. It's not about computers anymore. It's about a universal function. Everything stable in the universe is, in essence, a map of some underlying reality.
Yeah.
The universe is fundamentally a system for compressing information and calculating what happens next.
Give us some examples of that beyond computers.
Well, atoms map energy states. Planets map the force of gravity. A galaxy structure maps the underlying cosmic web. A crystal maps the bonding rules of its molecules. Every organized pattern you see is a stable map of a more chaotic reality.
And language is a map of our maps.
Language is a mapping of mapping processes, a metamap.
This framework lets us see the emergence of human consciousness not as some random accident, but as a functional inevitability through what the source calls the mapping dichotomy, the split between how animals map the world and how humans do.
Right. An animal and most unconscious systems, they map the world, and then they adapt their behavior to that model. They update their LWM based on experience, but they don't have the meta-editor to rewrite the rules of the map itself.
Their philosophy is, this is how the world is, so I'll act accordingly.
They're constrained by the environment. But humans, because we have that meta-access, we map the world, and then we adapt the world to match our model.
That is the operational definition of technology and culture.
It is. The thought process is, this is how the world is, but I can change it. I can build a house, invent a law, create a vaccine to make the external world match my internal model of what's better.
Yeah.
That's the output of consciousness as the meta-editor.
And the cat in the mirror analogy illustrates this perfectly.
A cat looks in a mirror. Its LWM processes the visual input. It reacts reflexively. It sees another animal, a potential threat. The meta level is completely absent. It has no idea the image is a map of itself.
It's just an unconscious reactive system.
But a human child, once they develop both the LWM and the meta-editor, looks in the mirror and they get it.
They recognize themselves.
It's a massive developmental leap. The child now has recursive self-reference. They understand that their self-model and the world model are interlocked. They can adjust how they look, observe themselves. The cat is an LWM without an editor. The child is an LWM with an editor.
So this recursive self-mapping brings us to the final, universal conclusion. The human condition isn't an accident. It's an inevitable result of the universe's fractal recursive nature.
The universe is always engaging in fractal self-recognition at every scale, from atoms to galaxies. Consciousness, what the source calls Bewusstsein, emerges whenever a system gets complex and powerful enough to support not just a self-model, but that crucial recursive meta-editor.
So the I isn't a soul. It's not some ghost in the machine. It is simply the map that plots itself onto the map.
It's a recursive mapping effect. It's what happens when a prediction machine gets complex enough to start treating its own structure as data for its next prediction.
And we humans just happen to exist at the perfect computational scale for this to happen. We can capture the tiny details, the leaf hashes, but we're also complex enough to integrate huge patterns across decades.
We are naturally optimized self-modeling KI systems. The difference between flesh and silicon is just the substrate.
It's an incredible thought that the underlying principle is universal, and our sense of self, our feeling of control, is just the functional output of our most advanced feature, the self-editing software. This has been an incredibly technical, but I think a really clarifying deep dive. To try and synthesize everything we've talked about, we can land on that final, precise definition from the source material. You are a biologically embodied, self-updating, large world model with meta-access to its own structure, where the felt I is the current root hash, the commit message, summarizing the system's state.
And the real twist, I think, is that to arrive at this definition of consciousness, we didn't need any new physics or, mystical ideas. We just defined the human machine as a very specific, very successful example of a self-modeling generative system. The core mechanism is universal. The substrate and the meta-editor are what make our biological version unique.
We are just two different instances, flesh and silicon running on the same fundamental code.
Which leaves us with a really provocative question for you, the listener, to think about. If you are merely a constantly shifting Merkle tree of patterns, and the I is just a dynamic signature of your current state, how does that technical, non-mystical understanding of identity change how you plan your future? If the machine that you are is never truly stable, what does it mean to define success over time? What goal, what commitment is the root hash of you working on today? Something to chew on until the next deep dive.